Yeah, of course, I'm Pedro. So we just share the presentation and yes, just okay, then just the slide.
Okay, thank you so much. So you will hear me just for a couple of minutes more. Frederico Felizardo will be doing the rest of the presentation, actually the main part of the presentation. Frederico Felizardo is a candidate young researcher with us at the University of Évora. He is doing a PhD, so he's one of your fellow colleagues. Most of the people here in the room, I believe, are in the same career position. So I really hope that you get to know each other, that you are able to share your problems and your ideas. That's what the fast track school is for. So just to start the fast track school, of course, we want to make a brief introduction to sustainable desalination strategies. What is desalination? Why do we talk about sustainability when we talk about desalination? And why does it make sense to talk about solar desalination? So maybe for some of you, this already know. We're not going to show anything new. To others, maybe this is new and might raise your interest into this topic. So we thought that it would be good to give you these basic materials to start a fast track school, and knowing that different people will be at different stages in these specific topics. So water scarcity, this is an evidence. I guess this is common sense that water is becoming more and more a problem. I guess most of the people in the room are either from Sicily or are living in Sicily. Sicily is a hotspot for this problem, as is all of Southern Europe. So the same goes for Portugal, for Almeria, and for Canary Islands. So all of the consortium is affected by this topic. So it's not by chance that we are developing research activities in this field. And what we can see along the past 100 years, 120 years, is that water consumption has been rising, but so has world's population. Okay, if we have more people, we should expect to have a higher water consumption. But the problem is that not only we have more population, but we are also using more water per capita. So the increase in water consumption is not proportional. It's not directly proportional to the increase of population. It increases ever faster because we are increasing ever more water per capita. So definitely, as we start facing water scarcity problems, the fact that consumptions are increasing more and more due to the increase of population, but also to the increase of the specific water consumption, it's definitely an important part of this problem. What we can see here at the same time is that climate change is there already. It's not a myth, it's something we can feel already in our daily lives. And what we see here are the medium temperature increase scenarios for 2010 and 2030 in the 3-degree scenario. If we would show here the maps for 1.5 degree increase, 2-degree increase, the graphics will be similar. Possibly the values here would be different. But what we can see is that definitely Southern Europe is going to be affected more heavily by climate change in terms of temperature increase and precipitation rainfall decrease. So this will further increase the water scarcity problem. And as of today, what we can observe already through these water exploitation index, which gives us a measure of how much water are we consuming over the resources we have available. So this is on a quarter base. We can observe already that quite a few countries are facing very severe water scarcity conditions in some parts of the year. So water scarcity in this sense is defined as having an index over 40%. What does that mean? That we consume more than 40% of all the available resources. That's where we need to start. And we can see that quite a few countries are already in these conditions. Spain, Italy, Portugal, Turkey, Greece, Malta, and look at Cyprus. Cyprus has an index of 124. That means that Cyprus is consuming 24% more than the resources they have available in Q3. So definitely we have in all Southern Europe water scarcity problems today, not in the future. Today, these water scarcity problems will be further increased with climate change. This is something we already know. Other things we know. Irrigation, that's the major source of water. So agriculture is the main customer of water as of today. And where are we getting this water? Well, mainly from freshwater resources, which are only 3% of the water resources we have available. So the remaining 97% of these resources has a small problem. Saline water, right, or brackish waters. So we cannot use them directly in agriculture. Not for agriculture or for any other human activity. So the rest, the remaining of water consumption goes roughly 20% to industry and 10% for domestic uses. And what we can see already in terms of uses of water is that agriculture definitely stands for the highest consumer, but the energy sector is actually a very significant user of it. So if we see here, in terms of the volumes used, they are even higher in the energy sector. The difference is that in the energy sector, we do not consume all the water. We consume some water, but we use the water through abstraction. For instance, for cooling purposes in thermal power plants. Thermal power plants use a lot of water for cooling. Okay, so they are not consuming the water, they consume just a fraction, but they need to have water resources available, otherwise they cannot operate. So, and then of course we have public water supply, which also abstracts a large amount of water, deals with a large amount of water to be able to produce what is consumed. So when we talk about water consumption, we need to think about also about water abstraction, which is also needed. These are water volumes that we need to produce consumption water. And what we can see here in the projections we have regarding consumption for the coming years, we are right now here, roughly, so 2040, is that we will have higher and higher energy consumptions associated with the production of water. And what we can see here in the forecast is that desalination will start playing an ever higher role in terms of the share of energy consumption for water production. And there is definitely a link, a nexus between water and energy. We cannot produce water without spending energy, and we cannot produce energy without having water. Okay, there is a very strong link between these two things. And what we bring you here is roughly, of course, these are not the values of any specific equipment of any specific installation. These are average values of energy consumption or specific energy consumption in terms of kilowatt hour per cubic meter. I guess that's what we need to have in mind between water supply, wastewater treatment, and desalination. And what we can see there is that whenever we open a faucet, we get water and we spend energy. And this is not really in our mind when we just fill a glass of water. It's not in our mind that we are actually spending quite some energy. Like almost 1 kilowatt hour per cubic meter. This definitely does not come to mind to a regular consumer, but this is there. And if we want to shift towards new water resources, besides fresh water, so to saline water resources through desalination, this number is multiplied by 10. So definitely there is a nexus between water and energy. This is something that you especially need to have in mind. We need to produce more water, so we will need to use more energy for that. When we go towards new resources, most likely through desalination, we will need to spend even more energy. And that's where we start thinking, where are we getting all this energy? And when we look at the solar resource map and the water scarcity map, what we can see is that there is a coincidence between water scarcity and solar resource. So the regions where we have less water are the regions where we have more sun. It's not by chance that the regions where we have more sun tend to be a bit more desertic, so less biomass. What does that tell you? If we don't have that much biomass, because we don't have water, right? As soon as we start adding water and heat, then we have tropical regions. We have a lot of biomass. But if we go to intertropical regions, we don't have that much water and we have a lot of sun. So they tend to be more desertic. So there is definitely here an opportunity to bring together solar energy technologies and solar desalination technologies. That's why we talk about solar desalination, and that's why we see that this is definitely a very interesting system. Okay, I would pass now to Frederico. Frederico, please.
Hello, everyone. So I will just do a briefly presentation about the technology and energy consumption accordingly to the water production of the technologies. So the desalination process and technologies could be divided in 4 main subjects accordingly to the energy sources. So can be thermal energy, and we have this kind of technology that using thermal energy. And for electric energy, we have the main technologies that use only electrical energy to produce water. So here we can see that we can divide in 4 main parts: the thermal, the mechanical, and the electrical energy and chemical energy. So this is the main subjects. Here I can show you the current global capacity of desalination. So how it is divided on the globe. So you can see that the Middle East is the main country that produce more desalinated water. We can see from this map that the Middle East and North Africa countries have the biggest desalination capacity. And here on the left side, on your right side, you can see how it is distributed accordingly to the main source water, how it is distributed along the globe. So you can see that the seawater is mainly focused on this region, north of Africa and south of Europe, and here on the California coast of the States, and here most in Europe. What we can see that according to the statistics, exist 100,000 operation facilities. So mostly are divided in the Mediterranean region, as you can see here on this map. So there is at the moment 2.37 billion cubic meters of capacity, desalinated capacity. So it is important, as Pedro referred before, since we are in a region that we have a lot of sun, we can start thinking and using the renewable energy sources such as PV, for example, to help us on the desalination part, to be coupled with desalination technologies. And in that, we can use our seawater to produce more water to be available for agriculture and for human consumption. So, as I speak before, the desalination facilities across the EU members are mainly in the Mediterranean region. So that's why it is really important to develop this kind of project that help us to understand better how the desalination could be important. So here we can see the four main technology that are used at the moment. So the reverse osmosis, the MSF, the MES, and the ED. So we can see on 2020 that for all the technology uses, the reverse osmosis is the one that are being using in higher scale. This is related to the Mediterranean regions that they are mounting a lot of reverse osmosis power plants to produce energy to help them for the human consumption and for the agriculture part. So we can see that the technologies that use heat process, caloric process in Portuguese. So you can see that they are getting a decrease, and technologies like reverse osmosis that is better to assemble, that is better to couple all together, that is more or less easier to operate, and our partners can explain that later. You can see that they are getting higher capacity along the years. So here I can speak a little bit in the part of Spain data. So here the seawater desalination parts that use recover energy equipment, they in the beginning of the 70s, they start using the technologies of heat process, and from the 19th, they changed it for reverse osmosis. So here you can see how the energy consumption to produce 1 cubic meter of water started decreasing. This chart can provide that information. So in the beginnings, we are getting, for example, 22 kilowatts hour per cubic meter. And since the years are passing, we change it for reverse osmosis, for example, and we are getting a decrease of the energy consumption to produce water desalinated. So, as you can see, one of the biggest problems to use the reverse osmosis is we are depending on the salinity of the water. So that's one of the main problems. But in terms of what we want to see, the energy consumption to be reduced, we can get better values. Here I can make a simple comparison regarding the water source. So we have the surface water. This is the groundwater, the wastewater treatment, the wastewater reuse, and the seawater. This is how can the energy consumption per kilowatt hour accordingly to desalinate 1 cubic meter of water or to treat it 1 cubic meter of water. And we can see how the energy requirement for each kind of water source that we have. And that is a range of values. So maybe later we will have high precision values, but now we can see that the energy consumption, for example, for the seawater is around 2.5 and 8.5. I think this 8.5 is too high at the moment, but it's on this range of energy consumption that we need to produce 1 cubic meter of water. Despite of energy costs, seawater desalination is the most suitable solution for water scarcity. And here, what I can show to you is, again, accordingly for the technologies, comparing membrane technologies and thermal heat process technologies, that they have, the thermal ones don't have restrictions for the feed salinity. And as I speak before, the seawater we have a feed salinity needed. So, but for example, for the thermal ones, we can see how it is the range of energy needs, and the seawater we can check how are the energy needs for the reverse osmosis for the membrane technologies. So, and what more? So this is again related to the Europe. What we can see here by colors is in all the coast on North Africa and Mediterranean region. So you can see the change of colors. So orange for yellow. This is a study that they have made. So how could be the better regions to couple real renewable energy and desalination technologies to produce seawater. And this is shows how is the energy costs per euro cents per kilowatt hour. What this means? Here in these regions that we have the orange colors are the suitable regions. The red ones are the most suitable. The suitable regions to implement systems, renewable energy systems, in this case PV arrow, that is the most simple ones, to produce desalinated water. So we can see, since we are in Portugal, Spain, Italy, Greece, so we are in a profitable area to couple PV arrow with desalinated technology, in this case reverse osmosis. Sorry. So, and now I will ask you, Pedro, again. Sorry. We will.
Okay, just to finish the introduction. So it's clear that we need more water. It's clear that desalination, it's an interesting solution for using new water resources, namely those coming from saline waters. We expect to have doubled the capacity of installed desalination plants along the next 10 to 12 years. We know that we need to take into consideration that we will need to consume more energy to produce these new volumes of water. And despite the energy consumption of desalination technologies has been decreased over the course of the past 20 years, very significantly, I must say, still this is something we need to take into consideration, and especially to think about the possibility of coupling solar resource and water scarcity through solar desalination. It is important to mention that the slide Frederico was showing, which was displaying electricity production costs based on solar PV. They were showing values between 5.5 and 8.5 euro cents per kilowatt hour. So these are rather different values from those we could think or we could see 20 years ago when we were first developing a PVRO concept. The costs back then were really prohibitive. Today, solar PV, especially in Southern Europe locations, is the cheapest way of producing electricity in absolute compared to any other possibility, including fossil fuel based. Okay, so definitely there is an opportunity here, and we need to be aware of this opportunity. And besides that, we have a range of technologies, so not only reverse osmosis, which has some operation conditions, but there are a number of other technological options which enable us not only to deal with different volumes, so systems of different sizes, both for centralized production or for local production, but also with different feed water conditions. So more saline, less saline. So there are technologies covering a wide range of operation conditions. Of course, some of them are already under application, others are still undergoing basic research efforts, and that's why we need more and more researchers working on these fields as you potentially are. So you will have, as in all other presentations, you will have a list of references we have been using to produce these materials. And again, the materials will be accessible publicly after the fast track school. And Giorgio, I guess we still have time for some questions. So if you have any questions, any comments, any remarks, please go ahead, both here and online. I hope our online attendants are there.
Or even they can write possibly a message to us, and let's check this very moment. Okay, just to be sure that okay. I don't think that. Oh, sorry, someone. Okay. Let's see. Maybe in the chat. Yeah. Andrea, can you read the question? Or maybe just connected, perhaps.
Well, I mean, online attendance, actually, you can unmute yourselves and
Yeah, exactly.
and ask or make directly your comments. And of course,
well, if I may say, Pedro, I mean, thanks for this very, very wide presentation on this important topic that is, you know, sustainable desalination for sustainable water use. There is a big problem, I think you have highlighted at the very beginning, that we are going to face within the next 10, 20 years, by 2040, 2050, the shortage of water, of course, not in all parts of the planet, but at regional levels. There will be for sure a different level of water crisis, because natural resources, I mean freshwater resources, are not abundant. And of course, the demand for water will increase significantly by 30, 40, 50%, which means that desalination could be possibly one of the options, if not the only viable option. So it is important that we address this point, developing, of course, state-of-the-art or beyond state-of-the-art technologies. In the future presentation, maybe I just want to say this point. So desalination, of course, is energy intensive. You have just highlighted this point, and also produce brines. So there is also the point of impact on the environment. And of course, within this project, we are taking care of all these aspects. Exactly. The future of desalination, sustainable desalination, a circular approach to lower down environmental impact, and to turn within the typical circular approach what is a waste, a byproduct, to brine it into a valuable product, into an opportunity for other value. So I think it is very important that we all, let's say, approach the next presentation within this overall framework that you have.
In Portugal, even information from this week, in Portugal, the first, well, not the first, actually the second, because in Portugal there is a desalination plant in one of our islands since 30 years ago or 40 years ago. But in mainland, we are now, it has been approved, an public investment in one desalination plant in the south of Portugal, in Algarve. And this week it has been announced that there will be water cuts now in winter for agriculture, and actually that they will prioritize saving trees. That's where we are right now in Algarve in winter. So this is definitely
is the very same here in Sicily. This very moment, I was looking, you know, the news a few days ago, and there were interviews to local farmers near the Etna region, Catania Valley. It's a very popular farmers area for a lot of different productions, and there is water shortage. So they are pumping, extracting water from the underground during winter, which is something that they never do during winter. Okay, so they have to do irrigation in this way, and of course, underground water will go down. The depletion of the underground waters is extreme at this very moment, and they don't know what to do. So it is critical. We're in winter, January, so it's a big topic, and I believe also I think in the Spanish region there are similar problems. So it is something we have to realize and try to devise.
There will be a lot of work to be done in the coming years for sure. Well, if there are no questions from online attendants or from the people in the room, maybe we can.
Maybe we can just stop for the coffee break that is now at 10 o'clock now. But of course, we'll be back at 10:30. Coffee break will be served in the next room. Okay. And so, well, see you in a moment. Thank you. Yeah, of course, people that they can stay connected online. We will start again at 10:30 with the following presentation. So there is half an hour break at the moment. Okay. Okay. Hanno sentito?